Okay, so let's get started. So maybe a week ago we talked about the timing of the final project, and it seemed like there was a reasonably strong consensus in favor of having it due earlier rather than later. I assume that you guys who are taking 201B knew the time of the 201B exam was the Monday the 16th, and were saying that you preferred earlier in light of that. So if nothing has changed for many of you, let's go ahead and have it be due the 13th of December, so you can make your travel plans based on that. Are there any comments or reactions to that? So there's a bit of discussion on the discussion board over the weekend about the enclosing environments question, and so I just wanted to go back to that example briefly just to pick up on that a little bit. So this was the basic example. We have this function f that creates another function g and then returns that function, and then we run that function. So we return g, gets assigned to the symbol h, and we then evaluate h for some value, for the value of 3. And we saw that when we did this before, that the result of then running h of 3 was 13 because it was finding this y equals 10, the enclosing environment for h is actually f here, because g was defined within f. So one of you asked, well, what happens if you do, I think it was this, and I just pointed out this morning that if you did that, well, f, you're going to start to run through f. It's going to create g. It's going to return g, and it's never actually going to get to this line here where y gets assigned to be 10. So y is never going to be created in the frame of f, so it's never going to be in the enclosing environment for g in this case. Is there any question about that? So the other thing I thought I'd do here, just because I was thinking about it as in response to the question on the discussion board, was we can just see a little bit more detail here that if I do this, I'm going to print out the name of the environment that is associated, that's the environment of the objects in F. So if I do that, now when I run h gets the result of f, it prints out this environment, and that's the result of this print statement. That is the environment of, that's the frame of the environment, the name of that frame of environment for the function f. And if we print out, if we just type in h, it says that the environment associated with h, namely the enclosing environment, is that same environment. So h not only has not only tells us what the body of this function h is, it tells us there's also this environment associated with h. And so if I do h of 3, of course I get back 13, we've already seen that. But sort of the interesting thing that I wanted to highlight here is I could actually, this environment of h now exists, I could actually play around with stuff in h. And so if I do, I think I maybe showed this last time, if I type environment of h, oh, well, okay, right. If I do ls and list the stuff that's in the environment of h, it says there's y and it says there's g, right? So that makes sense because when I first ran f, both y and g are being defined in f, okay? And that environment of the function f, so that has y and g. That's also the enclosing environment for h, and so h has within it this sort of, not only does it have the y, it also has the g, which seems a little bit funny because the body of h is the same as the function g, but it's because of this, because of how these things get set up in these in the frame of the function that this happens. But then I can do something that seems a little bit funky here. I can then say, okay, assign to the symbol y, to the variable y, the value 5 in that environment. And now if I run h of 3, it should recognize the fact that the value of y inside that enclosing environment has changed. So presumably, since h is going to be x plus y, it's going to be 3 plus, and y is now 5 in that enclosing environment. And so now I'm going to get 8. And I could actually do the same thing by saying, we haven't actually covered this yet, but you can work with variables inside an environment using the $sign operator, just like we have in the context of data frames and lists. So I could do something like this, which kind of looks a bit funky. It says, okay, take that environment, and for the value y in that environment, assign it to be 1. So this is essentially equivalent to what I'm doing up here. And we'll see environments more in the next unit, so this will come up again. Okay, now if I do h of 3, oops, did I not run that? Now if I do h of 3, I get 4. Okay, so any questions about that example or extended example, or about any lingering questions about frames or enclosing environments? Okay, so let's switch back to talking about strings and regular expressions and patterns. So when I left off, I just said a few things about some of the basic string manipulation functions in R. And I'll just highlight a few of them, and then we'll start talking about regular expressions. So I said there's the substring function that will extract out particular substrings from within a string, and that operates in a vectorized way. There's also an R function grep that operates essentially the same that we've already seen with the Unix function grep. So here this example is in R, and on this vector of character strings, I'm grepping for the string 98, and it says, yep, it's in the first one, it's in the second one, it's in the third one, it's not in the fourth one. So it's just giving me back the indices of which ones it's located in. And there's a related function called gRegularExpression that, if we were to pass in 98 as what we're looking for and give it this character vector, it will tell us actually where it matched the 98. So the result of doing that is it's going to give us back 4 elements, one for each of the 4 pieces of this character vector here. And for the first one, it's going to say that it matched in the 5th position, and the length of the match was 2. So it's matching that date 98, the 98 starts in the 5th position at date 98. And I'm not sure quite what that second attribute there means. And then for the second element, which was size 98, it also says, oh, it matched in the 5th position, and the length of the match was also 2. And then for the third one, where there were 2 98s in there, that was the x98, weights 98, it says, okay, I matched in both the 2nd and the 11th positions, and the length of both matches was 2. So it's giving us back information about exactly how the matching is happening. So this is not, so far this seems like a little bit silly because we can see for ourselves quite easily where the 98 is. But this is going to be really helpful when we get to doing more complicated matching patterns that might not be just too long and aren't just the fixed string 98, because it's basically going to tell us back where it found a match and that'll allow us to understand whether or not the regular expression syntax that we used is doing what we expect it to have done. And then in the 4th one, there is no 98 in the 4th one here, which is this just SDFSD. And so it just returns -1, which is its indication that it didn't find the pattern in that 4th element of that character vector. And then finally, sort of rounding out our string manipulation functions, there's a function that does substitution. And this is going to basically substitute in. It's going to look for this pattern, it's going to substitute in, and it's going to do it on this vector of characters. So in this case, it's going to substitute in 04, wherever the 98 occurred. And the G in front of the G sub and the G reg express stands for global. So it says, do the substitution wherever you find the pattern instead of just the first time you find the pattern. So that tends to be the one that I end up using more. There's also a sub, which only looks for the first one. Okay, so any questions about string stuff before we go on to the more complicated bit with regular expressions? Yeah, Jimmy?
What does the true mean? When you type the regular expression in the last line, it gives out true.
Oh, this one. Yeah, I'm not sure what this was the thing where I made the offhand comment a minute ago. I'm not sure what this second attribute is that it's returning. I'm not actually sure what's going on there. Any other questions? Yeah, Moshe?
One question about set seed. So does that work in the same way that using a variable where you do it in the global environment and you do it again in different seed and function?
That's a good question. So if we, yeah, I think that's going to operate with a side effect so that it has an effect outside of the function. So I guess we could test that by saying, so I'm going to set a random seed. Let's see if I can come up with an example on the fly here. Now if I do R norm of 1, I get back 1.26. So now if I have some function f, and its only effect is to set the seed back to 0. Whoops. Is this gonna? Do you think this question, or this example, illustrates your question?
Let's see, it's automatically set to 0 already.
Right. So it's set to 0. I generate a random number that's 1.26. If I generate a new random number right now, it's not going to be 1.26 because I've moved on to the next random number value.
Oh.
But if I run f, if this has a side effect that then affects the global environment, this should set it back. So now if I do R norm of 1, I should get the 1.26 again. Yeah. So it does have the side effect. So in that case, I guess I hadn't thought this through before, but I guess this is like CEX, where it actually, by doing something within the function, has an effect on the global environment, which is unusual behavior. So these are sort of two special cases. Other questions? Okay, so regular expressions. So we just saw an example where we're looking for the string 98, and obviously that's fairly limited in terms of what we can look for and what sort of manipulations we can do, and we want to be able to do more general pattern matching. So we've sort of already seen this come up a bit with grep, that we sort of needed to look for patterns, and I gave you some syntax where we used a little bit of regular expression syntax with sed in the problem on the first problem set, when I realized sort of after the fact that we needed to be able to do a little bit more complicated work with patterns. So the idea here is from within R to really learn regular expressions really well, but it's not, this is not just useful in R. You can then use this within Unix commands, or if you were working in Python or Perl, you can use all of this kind of regular expression syntax. So that's the idea and the motivation for what we're going to talk about here. And hopefully it's already pretty clear what the use of regular expressions is, that we can basically extract information from text, we can create variables from information that we find in text, we can do data pre-processing and data cleaning if we're able to work with regular expressions, we can treat text as, we can basically manipulate documents and treat them as data, and we can go out and scrape the web and extract data off the web automatically. So all of these sorts of things are going to be available to us if we're able to learn about regular expressions. And so the basic idea of regular expressions is they're actually their own little language that we learn. They're called a domain-specific language. And the idea is that this is a very highly specialized language for doing a particular task, which is working with patterns. So that's the background here. Okay. So in regular expressions, there are a number of special characters that we end up using for indicating different kinds of patterns. These are, hopefully I got them all here, they're the ones that are listed here. If I actually literally want to find one of these characters and not be using it as part of this language, then I need to escape it. So I need to basically put, in R, I need to put 2 backslashes. If I were looking for a $, literally, I would need to put 2 backslashes in front of it to look for it. If I were outside of R, you probably only need to put 1 backslash in front of it to escape it and actually look for that literal string. But if you don't escape it, then these things are going to have special meanings in this regular expression language that we're about to learn about. Okay, so the idea is we start out saying, okay, we can look for a pattern that's some fixed sequence of characters. We've already done that in the examples so far. But now we want to be more general. So the first way we can generalize things is we can look for any character that's in a particular class or set of characters. So the way that you do that is with these square brackets. So if I wanted to look for any of the numbers in the set 1, 3, 5, 7, 9, I would indicate it with syntax like this, and that would match any of those 5 numbers. If I wanted to look for any of these 4 lowercase letters, I would set up a character class like this. And there's a bit more, there's sort of an extension of this where if you have a dash and for particular sequences that make sense, like A to Z or 0 to 9, you can look for all of the numbers between digits between 0 and 9 with that 0 dash 9. So that would also define a character set. If I wanted to look for numbers or lowercase letters, I can combine these things like that, 0 to 9 or A through Z. If I wanted to look for any sort of white space in between a word, for example, spaces or a tab, a space or a tab, then I could do a character class that combines those two. And then I can negate things. I can look for all of the letters except for A, B, C, D by putting this caret power symbol in front of the letters. So this would look for E, F, G, H, I, J, etc. on down through Z. Okay, so that's one way of indicating classes. We can also, this essentially falls under sort of Perl-style regular expressions. There's also this other syntax that allows us to express a character class the syntax is basically square brackets and then 2 colons and then the name of a particular class. So the different kinds of classes that are defined within these types of classes are digit, alpha, alphanumeric, lower, uppercase, those are for lower and uppercase letters, punctuation, blanks, and spaces. And most of those are going to be relatively obvious. If you want to know the exact definition of them, you can look in the help under regexp in R. So if I then want to indicate look for a digit, I actually need 2 square brackets because the inner square brackets indicate this special syntax for defining the class, and the outer ones indicate sort of the generic that I'm setting this up as a character class. So here's an example. Actually, it looks like I left out the second set of colons. But suppose I was looking for any alphabetic character from the English language, or any number, or an underscore. Okay, so you can see how this might be useful if you're looking, say, for an email address. I could set up something that would match any of those things by first taking the outer brackets. That's going to set up my overall class. And then what this says is combine the underscore with the alphanumeric class. So this would then look for any of numbers, letters, or the underscore. And I would need to add in a second colon here. So as an example, let me just switch to R and we'll do this in R. So I'm going to set up a character vector here, and I'm going to look for either a number, so something from the digit class, or I'm going to look for an underscore. And so the way you would do that in R, now going back and using this grep function in R, but using it with this expanded functionality where I'm using regular expressions, is I pass in the pattern that I'm looking for in double quotes. I give it the character vector on which I want it to operate, and in this case, because I'm using these character classes, it's a good idea to specify this additional argument and tell R to use these Perl-style regular expressions. Sometimes this might work without it, but it seems like there are some cases where it doesn't that we ran into last year or the year before when we were doing this. So if I do that, and now I use grep and look for the pattern, it says, okay, I found a number or an underscore in the second and third elements of that character vector, but I didn't find it in the first one. Okay, so any questions about that? Okay. So suppose so here's a challenge as we're sort of making sure that this is starting to stick in our heads. What if I wanted to, let me go back to the slides. What if I were needing to look for spam in emails and I wanted to basically build myself a spam filter? How would I use these character classes to look for patterns like this where I start to see letters and things that should not be in words like numbers and these sorts of punctuation symbols? How would I start to look for that using these character classes? Yeah, Jeff?
So maybe you would search for things not matching alphanumeric periods or the at symbol.
Okay. Things. Right. So if you mean if you were looking for things that were not spam, you would look for things like that.
Oh, no,
Right.
well, I was saying if you look for things that don't match those characters, you would find the exclamation points. Right? If you were searching for spam,
Right.
so you wouldn't try to what are the alphanumerics, like the numbers and letters? Is that
Right. Right. Well, I guess what I'm saying is if you if you were looking, say, for Viagra spelled without it being an actual word because there's a 1 in there, what would we be looking for to find that pattern, for example? Yeah, Maliki?
Less is each side of the number, I guess.
Say it again.
Would you want to look for the letters either side of the number or an exclamation mark? Or if there's any way of ordering to do search for letter followed by.
Okay, so if we're trying to, there might be numbers sprinkled throughout an email, right? But the guiding principle here is we want to look for first a letter. Is that what you're saying? And then look for it, right? Okay. So what could we use to look for a letter as the first thing? What class could we use? Alpha? Okay, so we could do so we could start to build up regular expression like that, because we know that the first thing we want to find is we want to find a letter first. Equivalently, we could have done A to Z, capital A to capital Z. That would have worked as well. Right? And then we're starting to look, well, we haven't really gotten to the point of being able to do letters repeated, so let's ignore the fact that we need to work with repetitions of patterns. But if we then were looking for something that would indicate that it was spam, what would we look for after having found the letter?
We can use period any character.
Okay, but if we used a period, then that would then this would actually. So we're trying to distinguish, for example, between these two, right?
Okay, then digit.
Okay, so what are the things that could go wrong? It could go wrong in the sense of if it were spam. It could be a digit, right? What else could it be? Some sort of punctuation symbol, presumably, or an at. So perhaps we might start thinking about combining. Now, if we want to we would say the next thing we're looking for, if we're trying to find spam, is maybe we would look for a digit, or perhaps we could add in, or maybe punctuation. Maybe that class would be the right class to look for. So you notice what I've done here is I've combined two of these character classes and said look for either a digit or a punctuation symbol. Okay. Any thoughts on what might go wrong if I do punctuation here? Yeah, Brad? Okay, so we'd start having to distinguish between, right, what if we've got a word and then a comma, or a word and then a period, so we have to start to be more sophisticated about that. I suspect this would also match on single quotes, so if we had apostrophes in there, it would probably detect that and incorrectly say that was spam. So we'd have to start to get relatively sophisticated relatively quickly to start to deal with these different kinds of complications. So let's not spend the time to actually work through that completely, but that just sort of gives you a sense for how you'd start to build these things up, and then how you'd start to think about, well, am I getting quite the right thing, or am I going to get caught and find things that I'm not actually trying to find. Any questions about that? Yeah, Justin.
So is there a way to choose a class but exclude some characters of the class?
Not that I know of off the top of my head. You can obviously just enumerate all of the things except for that thing, but I'm not thinking of a way to do that more elegantly. There might well be, because that seems like a sort of obvious sort of thing that you might want to do. Okay, so the next thing we might want to think about is what if we want to find a pattern in a particular place. So there are two standard characters that get used for finding things at the beginning and the ends of character strings. So if I do, the caret out here, note that we already used the caret as the negation when it was inside the square brackets. It's a little bit confusing, but if you use it out here, it's a location indicator. And this says, look for an uppercase letter as the first letter of my string. That's what the caret means. And this says, look for a number as the last character in my string. That's what the $sign at the end indicates. So those can be helpful if you're looking for things just at the beginning or just at the ends of strings. And so if we did this in this example, running this here, if I look for an uppercase character at the start, it's going to match on this third string. If I look for a digit at the end, it's not going to find it in any of those, so it just returns back on a variable with no length to it. Okay, so I'm going to pause for a second and see if you can try and decipher what this pattern means here. Part of the trick with regular expressions is just starting to be able to sort of like parse them apart and see what's going on with them, because you end up looking at stuff like this, and if you haven't seen this before, this just looks like gibberish, right? But once you start to get a sense for what the things mean and start to be able to interpret and sort of read the language, then you can start to read off what it's actually saying. So take 30 seconds or so and see if you can try and figure out what that is, what pattern that is looking for. All right, someone want to volunteer and tell me what that's looking for? Yeah.
Anything that is not a lowercase letter from the beginning to the end of the expression.
Okay, so it's really looking for single character things, because it says it has to start with whatever's in here, and it also has to end with that. So it's only looking for a single character, and it's right, and it's only, as you said, looking for anything except for a lowercase letter. Yeah. No.
Could it be also that, would that give you a string, like a name that had a capital letter at the beginning and a capital letter at the end, or is it just?
So that should, that's a good question. Yeah, that should, I guess that would do that as well. So I guess I misspoke. So if it started with something that wasn't right, so it could start with a capital J and end with a capital A, or start with a capital J and end with a 9 or something like that. Sorry, yeah, so I was thinking of something incorrectly there. Although, actually, no, wait, let me correct myself a second. Let me recorrect myself. We haven't indicated that this, let's see, how would this work? Well, let's just try it out and see. So let's set up some text. So that's going to get C of, so let's say like that, and then something like that, and then something like that. Okay, and now we're going to do grep of, and I had this, and then I had not, what was it, lower? Yeah. Okay, so that's the pattern I'm looking for, and this is the text that I'm looking for it in. So it only found the single uppercase one and didn't match here, and that's because we haven't dealt with repetitions of characters yet, which is one of the next things we're going to talk about. So we'll get to that in a second. Okay, so this, we've basically already seen this. I think I'm going to skip over this. This just shows that we can use these regular expressions with gregexp, and that will show the match of one of these more complicated patterns, as opposed to where we used it before, where we were just looking for the 98. And this has this same result in terms of showing you where the match was found. And that we can use these regular expressions with gsub. So this is saying in our text here, replace a lowercase j with an uppercase j, but only if that lowercase j is at the beginning of the string. So if presumably, actually this example is not very good because I didn't put any lowercase j's later on in the string here. But that syntax down below there should replace these two initial j's here with their uppercase version. Okay, and then if you want to, there's an additional function that we can use that's helpful for showing exactly what was matched and not just where things were matched. So I could do, so let me set up this text here. Okay, and then I'm going to look for an uppercase letter at the start, followed by a lowercase letter, and now I'm starting to do a little bit of foreshadowing of these repetitions. This says look for one or more lowercase letters, and then look for a space. And then reg matches is actually going to show me what the match was. So if I do matches, that's the result of this gregexp, and matches will show me the whole bit that we've seen before of it'll show me whether there was a match, and if there wasn't a match, it'll be a -1, and then if it does find a match, it'll say where does the match start and how long is the match. So in this case, it found a match for Juan Carlos Ray as being uppercase at the start, some number of lowercase letters, and then a space, and it says, okay, the match was 5 long, because that's the match, and it starts in the first position. But then I can also do this reg matches on the result of the greg expression function. And if I do that, it'll actually show me what was matched, which is really helpful, especially when we're debugging and developing these regular expressions. It says, okay, nothing was matched, and then the one with the space is what was matched in the third piece. Okay, so let's start seeing repetitions, which we would need for going back to this spam example, or as we've already sort of seen in a few different contexts already. So suppose I were trying to take that spam example and actually expand it out to really match spam. I might have come up with something like this. I'm looking for alphabetic characters, one or more of them, followed by either a digit or punctuation, one or more, thinking that this would match to, this would be the indicator of the spam, and then ending in, this is going to mean 0 or more alphabetic characters. Okay, so that's how I would start to string together these character classes with different numbers of repetitions. So in this case, that wouldn't quite work, and that goes back to my comment about the apostrophe, which is that if we start to look for, it's going to treat the apostrophe as punctuation, and so this is not going to be quite a well-formed regular expression in terms of actually doing the detection that I want, because it's flagging this third one as spam because of the fact that I have an alphabetical followed by punctuation followed by alphabetical. Okay, so what are these repetitions? There are a few of these special characters that will tell us about repetitions. So I already told you what 2 of them were just in the context of that example. If I use a star, that's going to say any number, including 0, of the thing that comes before it. So this would be any number of digits. This is one or more of the thing that comes before it, so one or more digits. This is either 0 or 1 of the thing that comes before, so that would be 0 or 1 digit. And then we can actually start to say exactly how many copies we expect. So this is between 1 and 3 copies of a digit, and this is 2 or more copies of a digit. There's a comma, and then the space just indicates on out to infinity. So that is how we then start to match certain numbers of different things. Okay, and the period indicates any character. Somebody mentioned that before. I don't think I explicitly said that. So if we're looking for anything within brackets, we could do something like this. So we could say we're going to look for a square bracket. We need to escape it with the 2 backslashes. Then we're going to look for any number of characters inside the square brackets, and then we're going to end it with a square bracket. So so now we've got 2 square brackets and anything inside it. So that should match square brackets with nothing in it, square brackets with 1 character, square brackets with 2 characters, et cetera, et cetera, et cetera. Okay, questions so far? Okay, so the next syntax I want to mention is using parentheses. And we can use parentheses in two different ways. One of the ways is basically to group longer expressions. And the other way is to be able to refer back to something that we found within the parentheses. So if I wanted to look for an IP address, which would be a few digits followed by a period, a few digits, another period, a few digits, another period, and then a few digits. So, you know, if you were looking for something like 192.68.10.3, so that would be an IP address, I can do things like the following. So if I were to start to write this out, I might say, okay, we say between 1 and 3 digits, then a period, then between 1 and 3 digits, then a period, then between 1 and 3 digits, then a period, then between 1 and 3 digits, something like that. But this is just a repeat of 1 to 3 digits, say, followed by a period. So I could write that instead as digits, so between 1 and 3 digits, then an actual literal period, notice that I'm escaping it. And now I'm going to group that whole thing together into a pattern. And then I'm going to say, repeat that 3 times. Okay, so the parentheses allow me to distinguish and then use repetitions with a more complicated expression. And then in this case, I'd say, okay, and then follow that with a digit repeated between 1 and 3 times. So that's one way that we can use parentheses to group things together in this way. But we can also basically refer back to things that were in parentheses. So here's an example that, sorry, I sort of got the context for this wrong. This is not the FAO file that you guys had worked with. This was an example from, I think, from last year. But it's a similar, oh, I see what I was saying. Okay, so this next syntax would be useful for dealing with the country names with the commas in them from that FAO file. But the example here is actually from last year when I gave a slightly different problem on the problem set. So suppose we have a line of text from a CSV file where all of the fields are in double quotes, and for the most part the commas are used to delimit the fields, but in some cases there's a comma within the field. So that was actually the context of the country names, where we had like China, comma mainland, or Iran, comma Republic of, or whatever it was in the problem set. So this is a case where you might want to go in and look for these kinds of commas, but avoid these kinds of commas, and replace these kinds of commas with something else, so that the commas are only in the file in the form of the delimiter. So that's what I'm going to do here, and I'm going to use the parentheses, and whenever I use parentheses, I can refer back to what was found within the parentheses with / and then a number. So in this case, I only have one set of parentheses, so to refer back to whatever was found by the pattern within the parentheses, I can refer to that variable as /1. So it's sort of like the $1, the $2 that we saw with variables passed into Unix, into the Unix functions. So they're basically sort of unnamed variables. So what is this going to do? This is going to try and substitute in for some pattern, some piece of that pattern. So what is it looking for? So it's looking for this character class followed by a comma. So it's looking for not a double quote and not a comma followed by a comma. Because I don't want to find this, the double quote followed by a comma, and I don't want to find this, a comma followed by a comma. So I'm going to exclude those things preceding a comma. And then in the cases where I find things that are anything but these followed by a comma, I'm just going to replace it by whatever was found, namely the thing that was in the parentheses. So that's what this $1 is going to do. So what this should do is it should march along, and it should say, okay, does this match? No, because this is a quote and not a quote. Dun, 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 dun. Does this match? Yes, because this is preceded by something that's not either a double quote or a comma. And so in that case, it's going to match as capital N and then a comma. But the capital N is the thing that is found by this character class. So the capital N is going to get assigned to the variable /1. And so And then that's the only thing that it's going to find that doesn't have the pattern either double quote, comma, or comma, comma. And so it's going to go in and replace the n comma with just a capital N, but without a comma. And if we had instead had, I could have done, something like, say, A to Z, and then some other stuff, and then I could have had another parenthesis, and maybe I was looking for a space, and then a tab, et cetera, et cetera. In looking when R would be evaluating this, whatever was found matching this pattern would get assigned to //1, and whatever was found here would get assigned to //2, and so on and so forth. If I had subsequent parentheses. So that's the idea of being able to start to manipulate the things that were found in a more sophisticated kind of way. So here's another example of looking for a pattern. So I'm going to start to look for something that looks like a URL. So I'm going to say look for either HTTP or FTP, and that this is a new syntax. The pipe is indicating or here, and the parentheses serves as this sort of grouping operator. And then look for a colon, and look for 2 forward slashes, which I also need to escape. So that starts to look for things that look like URLs. Okay, so let's pause and see if we can try and put that into action. I want to look at this one first. So suppose that we knew that we had dates in the form of some of this 3 digits indicating the month, followed by a dash, and then the number of the day in the month. And suppose I wanted to take things like that and do some pre-processing. For some reason, I wanted to get it in the form that looks like this. I want to put the number first, and then a space, and then I want to put the indication for the month. So the question is, how would you write out a regular expression using the syntax that we were just talking about to be able to do this search and replace with the gsub function in R? So see if you can come up with the pattern you'd look for and how you would do the replacement, and we'll reconvene in a couple minutes and see what people came up with. Okay, so the way that I usually approach this is I first start to think about what's the pattern I'm looking for. And then I'm going to start to think about, okay, well, how will I indicate the syntax to be able to substitute in what I want to do the appropriate substitution and manipulation to get back out the thing that I want. So what's the pattern that I would be needing to look for in this case? Suppose I had some arbitrary text and in it was embedded sequences of characters that look like that.
So go for the uppercase, start by 2 lowercase.
Okay, so one approach would be to say, let me look for uppercase followed by 2 lowercases, but that's going to also match other stuff, right? That's not just the month indication.
I would put a group for that, and followed by the dash sign.
Right, but if I do uppercase and then 2 lowercases, I'll also find things like that, right? All right. So, but this is good because this is the sort of thing as you start to sort of work through this. This happens all the time. You know, I'll start to come up with something and be like, oh, that's either too general or not general enough, and then I have to sort of step back and think about other ways to approach it. So, other thoughts, Dustin?
So you would just list all 12 of them and then you would hide symbol.
Okay, so in this case, I probably need to enumerate all of them. There might be a more clever thing to do, but I probably need to enumerate, all of them because they're sort of arbitrary. So I can start to do something like Jan or Feb or March, Mar, or APR, and so on and so forth, right? Okay, so suppose that I'd written this all out. This is not actual syntax. I'm just being lazy here. Okay, so then what do I need to look for next? Okay, I need to look for an actual dash. And then what else? Okay, so I need to either look for 1 or 2 digits, right? Okay, so I could say do 0 to 9, and then 1 or 2 I could do as 1, 2, right? Is there any way that I could do this that would be a little bit more specific to finding actual dates that are legitimate dates? Okay, so I can't have, January 54th, right? So the first number has to be either, well, I need to have either a 1 or 2 or nothing followed by another number, right? So if I wanted to do that, I could do it as a 1 or a 2, 0 or 1 times, which would be that question mark symbol, if I remember correctly from what we saw in the PDF. And then I could have the 0 to 9. That doesn't quite work, right? Because that would allow me to have just a 0. So I could even start to try and get more sophisticated here to make sure that I excluded the case of just having a 0. Anyway, you can start to play these games to make sure that you're being really careful to do the matching of exactly what you expect. But let's leave that aside for now. So let's assume we just went with that. Well, if I want to do a G sub, I'm going to start looking for patterns like this, and I have to decide what to replace them with. So I'm going to have to put something in here to do the replacement, and then I have to give it my R variable that's going to be the character string. Okay, so how would I do the replacement using those variables that we just introduced? Yeah, Brad? Right. So we're going to need to refer back to both the month part of it and the day part of it, right? So let's start putting in parentheses here to do the grouping of the things that we're looking for. So I can do this to this. So that should then, whatever gets matched here should go assigned to //1. And then I can do the same thing here, and that should get assigned to //2. So now if I want to do the formatting, well, what did I say I wanted it to look like? I want it to look like this. So this would be //2 space //1. So if I just do something like that, that should look for this pattern, and then whenever it finds it, substitute in this replacement expression where this is just a manipulation of what was originally found. Yeah, Malky?
Sorry, why is it 2 rather than 3? Did it not pick up the dash as the second?
Well, the dash, we didn't put parentheses around the dash.
Oh, okay.
So the only things that are being assigned into these temporary variables are the things that are in the parentheses.
Oh, so it won't automatically.
Yeah, no, it's
realize there's parentheses inside or something means.
Right. It's just gonna it's gonna sort of ignore the. I mean, it's gonna look for this in terms of the pattern, but it's not gonna save it into one of these variables. Okay, so let's end there. We'll do a little bit more with regular expressions on Wednesday. In fact, what I'm going to do is I'm going to send out a note in a few minutes asking you to come up with some solutions to a couple of regular expression problems, and I'll ask you to do that for Wednesday. We'll go over those, and then we'll finish this off, and we'll launch into the next unit after that.